Hey there, YouTubers. I've been aiming to upload a video. I should have uploaded one when I had this circuit built, or actually running, but I didn't because it actually failed. I mean, it did work, but with the controller that I've got from mw&s, it didn't work with that controller. And the fact is, on the relay side, there's the relay side that says 12 volts, and then there's the negative side. Well, I would have thought the 12 volt side would have been switched, but it ain't that side that's been switched on and off. It's the negative side. With this controller, my idea was for the positive side to be switched. Well, that wasn't the case, so whenever I added positive to it, I automatically turned the controller on, since ground was common throughout this whole system, and it does switch to negative leg on it. So in all actuality, twice I burned up the 12 volt regulator on the charge controller, which I've replaced twice. The transistor MOSFET that they have on there is a NPN transistor, so it switches the negative leg of a relay. So with this setup, it would not work. I even tried it with a relay to switch the positive on this side and keep the negative neutral. That still wasn't the case, even though I had a 12 volt regulator on here, just in case everything went haywire to power the optocoupler. Alright, I'm going to show you, this is version 1 of my circuit, and it does work if I didn't use the charge controller. Those are the 4 MOSFETs that are bolted in place. They're held down by a bar of aluminum there. There's aluminum down below that where the MOSFET's set on, and then that piece of heatsink is mounted to this larger heatsink that also has a fan. This came out of a solid state controller from work. Had the fan connected to this area here, which I'm taking it all apart, as you can tell. I'm not going to use it anymore. All these parts will come off. I'll salvage this piece off, and all the transistor MOSFETs will come off as well. These are my inputs, which handle the 8-gauge or a 6-gauge wire going to it. And there's the input there, where you put the 8-gauge wire. And also the other things I'll change. You see the copper there? There will be a heavy piece of solder across there with an extra piece of wire, so this can handle increased current. I have had this up to 50 amps, no problem. The traces did get a little warm, so anything above 50, I would say I'd be burning up the traces, so I'll have to put heavy duty traces on there, which I have had done on the version 2.1. There actually was a version 2.0, but I didn't like it, so I changed it again to 2.1. And I'm going to show you some of the steps I went into making this. Alright, I'm going to go to the ideas of what I was using. This is the system I was using. That's the optocoupler. There's their MOSFET, but I've, of course, used my 750 watt MOSFETs. And there's the wiring diagram for it. Same wiring diagram. Instead of just one MOSFET, I have 4 MOSFETs in parallel, all controlled by the gate from the optocoupler. But all the other values are the same. Now before, if you see, it's 12 volts, and then 12 volt DC. One side's negative, one side's positive 12, and then here's the ground leg here. What I did, I had ground here to there, you know, common. And I had 12 volts here and here common, and over here, you know, it was separate. You know, this load here, it wasn't 12 volts I was using, of course, my 24 volt from my batteries through my charge controller through the MOSFET. So that's how that turned that system on. This here, to my knowledge, would have been if I use 12 volts to turn it on and off, works perfectly. But with the charge controller from mw&s, the negative side is switched. So since I had those two common, what happened when that was switched, it burned up the 12 volt regulator. Somehow it did it. And, you know, of course it just wouldn't work. So my new design that I have, this side here is completely separated. And this side's all one unit right here, as you will soon see on version 2.0. Alright, and here's the MOSFET that I used. It ain't pulled up there. Let me find it here. There's my MOSFET. It's a Fairchild MOSFET, 44 volt, 500 amp, 0.12 ohm N channel SMPS power MOSFET. You use these in radios, power supplies, all kinds of different pieces of equipment. And what I really wanted was the wattage to be as high as possible at 750 watts. So if I run 30 volts across it, of course I give you what your current would be. It says its max current amps is 44, and depending on your degrees, 100 degrees, 32 is your max, 25 is 44, 500 volts. And granted, if you use math, if you take 750 divided by 500, this ain't going to be this current. Alright, and the same thing, if you take 750 divided by 44 or 32, you ain't going to get that voltage. You always, if you do anything with MOSFETs or solid state controllers, wattage is what you want to look at first before you determine what other items it can handle. But this will tell you what it can handle up to on each one of those legs, alright, of this MOSFET. And the back side of it is the same as your drain. That's where your output power is, and there's your source. So I just let you know what power that can handle. Alright, here's what I used to design this. Let's make sure. Okay, this is my version 1.0. Before I had 12 volts going all the way through, which is I never did use that. This is my input of the negative. This is my output of the negative going to my charge control, or to my dump load, or whatever you use to power when it turns on. And my ground was all the same. This has all changed. This does work if you have a 12 volt switching system and your ground's all, you know, the same. Alright, and I'll show you version 2.0. And here's version 2.0. As you can tell, it's a big change between the two. Alright, on this version I have bridge rectifier there, bridge rectifier there. There's two different circuits here. Circuit 1 controls the LED portion, you know, that turns the system on and off. All that's a separate circuit. The ground is not common. The only common is the opposite side, where the MOSFET that's in the optocoupler, is the same. And it has its bridge rectifier, 12 volt regulator, 12 volt regulator. This is so just in case there's a voltage spike, it ain't going to burn up my system. There's a resistor here and a connector there, and what that's for is an LED. So when this system's active, the LED will come on, let me know that the solid state controller is on. These two connectors here is for the fan, so when this system switches on, it kicks on the fan, which keeps the system cool. There's two 1.2K resistors here because there's an actual LED inside the optocoupler. And on the opposite side, just as I showed earlier, this side is isolated to the actual controller side, or the side that's being powered. That side is what's isolated onto that side. And so far, this is that circuit here. This is the old circuit. This is the new circuit that I've been working on. I don't have the MOSFETs on it yet. There we go. Let me get these wires unwrapped here. Alright, these are the connectors. See, those are the two 12 volt regulators. Those two round things there, those are the bridge rectifiers. There's my resistors. There's only 5 of them. There's 4 1.2K resistors there. One of them is for the LED. The 222, that's for the other side of the optocoupler. That's to bring its MOSFET to a positive side. And that in there is to bring, once these transistors get into place, that'll bring those systems back to ground once this stops transmitting. Once that stops transmitting, this will be brought back down to ground, turning off the charge controller, or the solid state relay portion of it. But that's this system here. And these wires here are pretty much just salvage off of old equipment. These 4 wires here, the red black is for the controller side. The blue and white is for the switching side, where it turns it off and on, which will be able to be powered from my Coleman Air charge controller. So I'll be turning this on instead of a relay. So this will operate just like a relay. It'll be just like the relay coil, which will be isolated from the other side all completely. So well, there's that. That's my fan connector. I got to solder those to the wires. And this one here's got the LED, and I have tested this circuit. It does work, except for I don't have the MOSFETs in there yet. But everything tests out. All the electrical outputs test out. Now, the bridge rectifiers, you're probably asking, well, how's he got bridge rectifiers in there if he knows what he has it in? Well, that's for stupid people like me, for instance, or anybody for that matter. Positive, negative, positive, negative. I can accidentally switch them out, and guess what? You're still going to get positive, negative on the optocoupler no matter what. It's always going to be the same. So that's a safety factor where if the wires get switched, you ain't going to burn up your charge controller, and you will not burn up your solid-state relay. Alright, another feature that I'm going to be working on, the reason why I've moved these contacts down where they're up higher on the other one, the reason is there's going to be a hole drilled here and a large hole drilled there on that side, and that's so I can have access to the screw underneath of it. There's a screw there that holds that bar down all the way across. It's actually an Allen bolt, and that way I can just put the Allen screws through and bolt everything down without bending these back and forth, and then I'll have standoffs on both sides mounting this down there so it looks really good. Alright, well, that's pretty much that. Maybe within next week, because I do have more MOSFETs ordered, I'm going to salvage these off here and I'll put them on here, because I'm going to build another one of these. I'm going to build multiples just to see how good they work, and if they do good and I make a good package out of them, I'll probably try selling them. But other than that, that's it. I hope you enjoyed the video. If you have any questions, comments, please feel free to get a hold of me and ask me questions. I mean, I have no problem with that at all asking questions. Alrighty, I'll talk to you YouTubers later. Bye.